The ground shakes and you hear a loud cracking sound. Oh no, the dome is failing. Everyone runs to their escape pods to evacuate. People are pushing and shoving. The Earth-like atmosphere in the dome is going to be compromised, and you'll be exposed to the thin elements on the surface of Mars. Everyone rushes to put their helmets on. The crack is getting bigger by the second, and people are panicking, trying to get on the escape shuttles as quickly as possible. In the chaos, they all jam into the wrong ships, and there isn't any room for you. Red warning lights begin to flash in the dome, and a voice rings out, telling everyone to put their helmets on. The Martian atmosphere is only minutes away from rushing in, and humans won't be able to breathe otherwise. This is just your luck. You only just arrived on Mars. As the ships zoom off into the distance, you wonder what you should do. You call out for help, but no one answers. Suddenly, a robot guide rolls up behind you, and you hear a faint noise coming from its speakers. It says, "No one can hear you because the atmosphere on Mars is so much less dense than on Earth. It also has a lot of carbon dioxide, which absorbs sound waves. Even if a loud concert was happening just 30 feet away, it would sound like it was miles away. Would you like me to assist you with anything?" You ask it for help, and it shows you a 3D layout of the entire dome. You can see a few other shuttle stations, so you decide to aim for them. Unfortunately, you're going to need to get to the opposite side of the dome to reach another shuttle station. Just as you begin to panic and wonder how you could get there, the robot transforms into a bike and tells you to hop on. You get in and cruise through the city, looking at all the empty buildings and streets. The crack is getting even bigger, and tiny pieces of the dome begin to fall from above, like snow. When you arrive at the other station, the last few people are boarding the only shuttle. You chase after them, desperately trying to get their attention. As you ding the bell on your bike, though, it barely makes any noise at all. Their ship pulls away before they can notice you. You ask why sounds aren't working, and the robot explains that you can barely hear high-pitched noises on Mars. The carbon dioxide makes high-pitched noises, like bells and chirping birds, almost impossible to hear. If only you were still on Earth, they might have noticed you. The robot tells you that there's one last chance to escape. He transforms into a tiny spaceship. You get in, and he flies through the crack in the dome out into space. It's going so fast that you should be back on Earth before long. Just as you're starting to relax and enjoy the sights of space, you see a red light flashing on the robot. You ask it what's wrong, but you get no response. Suddenly, you realize that you can't hear anything in space. Sound travels in waves, and it needs something to move through, like air or water. Space is a vacuum with no air, so you can't hear any sounds at all. The spaceship suddenly changes direction and blasts off away from Earth. You try to steer the robot in the right direction, but you can't figure out how to get its attention. The ship charts a flight all the way to Venus. As you get closer, the turbulence kicks in. Venus has winds faster than any tornado on Earth. You keep getting swept away, trying to find a safe space to land in. The robot manages to keep a steady course, despite the wind throwing it all over the place. You can already feel the heat through all the layers. Finally, the robot spots a small cave in the distance and attempts to land there. As soon as the robot touches ground, it morphs into a spacesuit you can wear, so you're safe in the extreme environment. Today's forecast in Venus? Heat. Extremely boiling temperatures all day and night. Expect clouds of sulfuric acid and gale-force winds. The atmosphere is mainly made up of carbon dioxide, so you can expect your voice to drop deeper too because of the planet's dense atmosphere. It's only the second planet closest to the Sun, but it's actually the hottest. Its atmosphere traps the heat from the Sun and keeps it around the planet. It's actually so hot on Venus that it could melt lead. If you were cruising by with the spaceship, the whole thing would melt in a matter of minutes. Luckily, you have this indestructible robot armor. You try to ask the robot how to get back, and your voice sounds crazy. Your vocal cords vibrate slower here than on Earth, which makes the pitch lower. But at the same time, the speed of sound on Venus is a lot faster, making it more squeaky. Then, the high carbon dioxide content in the air creates a weird effect that tricks your brain into thinking that the sound source is small. Overall, you sound something like a cartoon duck. You look out across the horizon and see many hills and mountains scattered across the plain. But the robot tells you that many of these are volcanoes. Venus actually has more volcanoes than any other planet in the solar system. Scientists discover more than 1,600 only on the surface, which could mean there are even more than that still undiscovered. Yeah, maybe being here all day isn't such a good idea, and not just because of the heat. A single day on Venus lasts 243 Earth days. In fact, a day on Venus is longer than a year, because it only takes 225 days for it to complete a rotation around the Sun. It's hard to understand each other, but you eventually manage. The robot tells you that it just got lost, and that you'll be back on Earth in no time. While walking around the cave, you realize that you're actually inside a volcano. You tell the robot to hurry up and get you back home before it erupts. It's clearly not very good at navigating space, though, because it's not long before you end up somewhere else. You're now on Titan, Saturn's largest moon. The moon is so large that it's even bigger than Mercury, the planet closest to the Sun. The spaceship arrives in the atmosphere, which feels and behaves similar to Earth's. The only noticeable difference is the orangey haze hanging in the air, which makes it a lot more difficult to see. As you descend towards the moon, the robot detects signs of cyanide gas all over the surface and fluffy clouds made out of iced methane. You land on a soft spot and set about trying to get the robot to take you back to the right place. At least this time you're not sweating. The robot transforms again and begins to scan the surroundings. The atmosphere is around 60% thicker than on Earth. Walking around feels like you're wading through maple syrup. There is a really high nitrogen content in the air, so things sound surprisingly similar to how they do on Earth. You tell the robot you really want to get home now, but it comes out as a loud, raspy shout. This is because Titan has more nitrogen than Earth, and because sound travels a bit slower. Luckily, you can still understand each other here. The robot tells you that it needs to absorb a bit more energy from its solar panels before taking off, so you have a look around. This moon is one of the only things in the solar system that has fixed bodies of liquid like rivers, lakes, and seas on its surface. You can understand why the robot got lost now, given how similar Titan is to Earth. Titan even has liquid cycles, with rain, evaporation, and condensation. This isn't water like back on Earth, though. The main liquid here is methane. Scientists think that there may be volcanic activity, but instead of molten hot lava spewing out, it's water. Other planets, like Mars, have ice on the peaks of their mountains and evidence of water beneath the surface, but nothing is as close to Earth as Titan. Some scientists believe that this moon could be our next home billions of years from now. The Sun's temperature will increase by then, making the Earth's atmosphere uninhabitable. By then, Titan's cool temperatures will be good enough to create stable oceans and sustain life. The robot finally gathers enough electricity to fly away, so you can head home. It'll be nice to have a normal conversation where your voice doesn't sound like an exaggerated cartoon. Whew.
You accepted an offer to participate in an experimental program that'll take you and your colleagues to different planets in the solar system to see how humans can live there. As a volunteer, you dedicated your entire life to this study. You're 25 years old, and your destination is Mercury. Your colleague, Ryan, is 45. He'll be based on Pluto. Nora, 18, will go to Jupiter. Jeff, 65, will go to Mars. And Vivian, who's also 25, will head to Neptune. Each of you will have a unique chemical compound to boost your lifespan before reuniting. You're all in the launch pad and ready for takeoff. Each of you sits in the cockpit of your spaceship, and it blasts off right to your planets. Even though Mercury is the closest planet to the Sun, it's not the hottest. That honor goes to Venus. But it is the fastest planet to orbit the Sun. On Earth, a year is composed of 365 days. But on Mercury, you'll only have to wait about 3 months to celebrate the new year. 88 days to be exact. Your team's concept of time will change drastically. A part of Einstein's theory of relativity is that time can be affected by acceleration and doesn't flow steadily. It moves slowly for objects that are in motion, rather than a stationary observer. It's also affected by the gravitational pull. The closer you are to a large mass with strong gravity, the slower time will be. People can't perceive this phenomenon. Scientists estimated that the difference is around 90 billionths of a second over 79 years. But at different planets with different gravitational mass, the differences might be visible. Astronaut Scott Kelly went to space, while his twin brother, who was 6 seconds older than him, remained on Earth. When Scott returned, the gap extended to 6 seconds and 5 milliseconds. You arrive in your dormitory and unpack your stuff. Outside, you see the wasteland, and the temperature is above 800 degrees Fahrenheit. But at night, the temperature drops to a whopping -300 degrees Fahrenheit. That's because Mercury doesn't have an atmosphere to trap any heat to keep the planet warm like a desert. The magnetic field has solar winds from the sun that create strong tornadoes with hot plasma. After settling in and placing all your fabulous sci-fi books on the shelf, the ground shakes and knocks down some stuff. Mercury's surface has active tectonic plates that cause earthquakes. It's just something you'll have to get used to. You're able to have a video call with the rest of your colleagues for a quick catch-up. Ryan is on Pluto, billions of miles away from you, and has the worst reception. Pluto is considered to be a dwarf planet and one of the coldest places in our solar system, with temperatures reaching -400 degrees Fahrenheit, so Ryan doesn't really leave the dorm. He takes his webcam and shows you and everyone else what's outside his window. There are mountains higher than 10,000 feet covered with methane ice. Pluto needs 248 years to orbit the Sun, which means it'll take Ryan the most time to celebrate New Year's. No human can last for such a time on Earth, but the chemical enhancements make it possible. On this day, Ryan will have to wait 90,520 Earth days for New Year's. With gravity, he might age much slower than anyone on Earth. After he shows everyone around, the youngest one in the experiment, Nora, vlogs her new setup in the solar system's biggest planet, Jupiter. Jupiter is so giant that more than 1,300 Earths could fit inside it. That's like 1,300 grapes versus the size of a basketball. And even though it's that big, the planet completes a rotation around its axis in just 10 hours, so a day is considerably shorter here than on Earth. She shows you around her dorm, which resembles a fun playground filled with entertainment. The whole complex is sturdy enough to withstand the extreme winds that can reach more than 335 miles per hour. The people in charge of the experiment were smart enough not to place the complex in the Great Red Spot, an area with a hurricane-like storm that has lasted more than 300 years. And this spot is twice the size of Earth. Jupiter needs around 12 Earth years to make a complete orbit around the Sun, which is 4,307 days to be exact. This would mean that Nora would have to wait 24 Earth years to be 20 years old, technically. But Jupiter's gravity is a lot stronger than on Earth's, which means she might age twice as fast. After showing everyone around, Jeff, the oldest one, begins giving everyone a tour of his place on Mars. It's called the Red Planet because it's rich in iron minerals, which might rust. His bunker is classy and feels the most luxurious over all of the others. And it has the best view as well. You get to see the highest mountain in the whole solar system, about 3 times higher than Mount Everest. Olympus Mons is also a volcano, as if being the tallest mountain wasn't already something extraordinary. Mars needs 687 days to orbit the Sun, which is a little less than 2 Earth years. It may not be the quickest in the solar system, but it's not as extreme as Pluto. Mars also has weaker gravitational force than Earth, but with 25 hours a day, he may not feel the time difference compared to everyone else. Vivian jumps in late in the call to show around her place on Neptune. She used to live near some hills and mountainsides, so the windiest planet in our solar system isn't that challenging for her. It has a rocky core like Earth and an uninhabitable atmosphere. Neptune is blue because of the absorption of red light by methane in the hydrogen-helium atmosphere. She shows everyone a view from her panoramic window, and you can see all 14 of Neptune's moons and some cloud formations. A whole day on this planet is just 16 hours. Vivian would have to wait 164 Earth years for Neptune to orbit around the Sun, which is 59,860 days on Earth, beyond any ordinary lifespan for humans on Earth, but a giant tortoise could be okay with that. But with everyone using a special chemical compound, the experiment could be conclusive. Gravity is also strong on Neptune compared to Earth, so she might age just as fast as Nora on Jupiter. After the video call, you take a tour around the complex and find out that other people stay with you in different bunkers, and the same goes for your colleagues on the other planets. 1,000 years later. You've forgotten what Earth looks like. You've forgotten what the atmosphere felt like, and even the wind brushing against your skin. But you've made your place pretty cozy, with so much plant life and cloned animals from Earth in the biochambers. You completely forgot about the mission at this point, and suddenly got a notification about a video call to update everyone about your progress. You set it up and wait for everyone to log in. After about a minute, no one responds. You haven't heard from them since the last video call 1,000 years ago. But then, one by one, everyone joins the video conference. The chemicals in everyone's body, which is enough to extend your lifespan, doesn't affect your body physically. It doesn't make you age at the same rate as on Earth, but it slows it down quite well over 1,000 years. Not everyone looks the same. Ryan was 45 years old on Earth, but he's only aged 4 years with Pluto orbiting the Sun 4 times in 1,000 years. He's now 49 years old, but if he were on Earth, he'd be 1,045 years old. But since he was on Pluto with weak gravity, he didn't physically change as drastic as predicted. Nora was 18 when she went to Jupiter and is still the bubbly girl she was 1,000 years ago. It takes 12 years for the planet to orbit the Sun, which means she's now technically 30 years old on Jupiter. But with Jupiter's strong gravity, she now looks 60 years old. Jeff landed on Mars when he was 65 years old, and if it takes 687 days for a complete orbit around the Sun, then that would make him 596 years old at the moment. Instead of looking extremely old, the weak gravity on the red planet made him age slower relative to the time spent. He looks to be around 80 years old. After landing on Neptune, Vivian, who was your age, is now only 31 years old on the blue planet. It takes 164 years for it to make a full rotation, making her quite old. And with Neptune's gravity just as strong as Jupiter's, she jumped in age and looks like she's in her 70s. You reveal that you're 4,147 years old on Mercury. Since it only takes 88 days for the planet to revolve around the Sun, you're now technically the most senior amongst them. But Mercury's weak gravity makes you look like you're in your 40s.
Hey, listen up. Do you want to lose weight fast or gain more mass in just a few seconds? Forget all about diets and sports. We have an out-of-this-world way to do it: space travel. And now I'm taking you to the heart of our solar system, to the Sun. Hold on and bring your shades. There's no solid surface here, just hot liquid plasma. So take your heat-reflective suit and stay on the platform just above the boiling surface of the star. On Earth, you weigh 135 pounds. But here, on the Sun, your weight is about 3,600 pounds. That's like a small sedan or a hippo. Hey, just saying. It has to do with gravity. The bigger and denser a space object is, the stronger its gravitational pull, and the heavier your body feels. The Sun is 99% of the mass of the entire solar system, but although the star is 333,000 times as heavy as Earth, it's also much bigger. That's why gravity is only 27 times stronger on its surface. You can't stand up straight here, you get pulled down by gravity. And if on Earth you could lift 135 pounds of your own weight, here you can only lift a small pumpkin. Happy Halloween! Moving on, Mercury, the closest planet to the Sun, is very hot, about twice as hot as the maximum temperature in your kitchen oven. You jump down onto the rocky surface of Mercury and step on the scales. They show only 51 pounds compared to your real weight of 135 pounds. Mercury is almost 17 times smaller than Earth, but its core and crust are very dense, so the gravity here is only 2.5 times weaker than that on our home planet. It means you can jump 2.5 times higher here, and you feel much stronger. You can lift a big gorilla, but don't forget to make it wear a spacesuit with an oxygen supply. When night falls on Mercury, the planet cools down incredibly quickly. The temperature drops to 3 times as low as at the North Pole. So let's get out of here before you freeze completely stiff. The next planet is Venus. Oh, there's a nasty smell. It's the sulfur dioxide in the air. It would also smell like this near a volcano on Earth. You get on the scales and 122 pounds, almost as much as on Earth. No wonder Venus and Earth are called twin sisters. This planet has almost the same size as ours and only 20% lighter, so it has almost the same gravity. But you couldn't live here because Venus is the hottest planet in our solar system, and the atmospheric pressure on its surface is 92 times as high as what we have on Earth. You'd only feel the same pressure if you dived 3,000 feet underwater on our home planet. Without special equipment, you'd be crushed at such a depth. Your spacesuit is made of titanium to withstand this kind of pressure, just like an atmospheric suit for deep-sea diving, and it weighs about 830 pounds. It's like carrying the weight of a motorcycle. That's why you feel weaker here than you do on Earth. But moving on to our home planet, or more specifically to its satellite, the Moon. Several astronauts have been here before. You might have seen videos of how awkwardly they moved around, sometimes even falling. That's because gravity on the Moon is 6 times weaker than on Earth. Your solid 135 pounds of weight turns into 22. So now, you weigh like a plastic shopping cart. On the bright side, you can now lift 6 times that weight. You can flip a car or lift a pony. You can probably even lift the lunar rover that's still standing here left by the last moon mission. One of the astronauts, Alan Shepard, hit several golf balls here, and one ball weighs less than a half an ounce on the Moon. Hey, maybe you can use all that power to clean up the stuff people left here. That's about 250 tons, including rovers, broken space probes, lunar module sections, golf balls, and the like. Nah, let's do the cleanup later. Now we're going to Mars. Hey, you're the first human on the surface of the red planet. And the first thing you do is weigh yourself, of course. 50 pounds, almost 3 times less than on Earth. It's even less than the weight of a capybara, a big rodent from South America. That's because Mars is 50% as light and 10 times as small as our home planet. And since gravity is weaker here, you become 3 times stronger. You could lift 2 of your friends. But this kind of gravity is actually a problem for people. We're planning to colonize Mars, but our muscles are used to the constant gravity of Earth. They won't work at their full capacity on the red planet. This will cause health problems for the astronauts, so they'll need to exercise all the time or tie weights on themselves to become heavier. They'll have to carry at least 10, 20-pound dumbbells to get close to their real weight and keep their muscles toned. Now, a quick trip to Jupiter. This is a gas giant. Hey, again with the gas. And it doesn't have a solid surface. All you see are dense clouds, so it's probably best to stay on the platform. Jupiter is 317 times as heavy as Earth, so the gravity here is much stronger. Your scales show 340 pounds. That's like the weight of a big wild boar on Earth. Now, you can barely stand on your feet in your spacesuit. You feel very weak. The maximum weight you can lift here is 60 pounds. That's as much as a husky dog weighs. Let's take a look at Jupiter's moon, Europa. You stand on the scales and see 18. Yup, gravity is so weak here that you weigh like a garden gnome. At the same time, you can easily lift 1,000 pounds. That's like a horse or a grand piano. With that kind of strength on Earth, you could flip a school bus or lift a small car over your head, if you wanted to. Moving on, Saturn, another gas giant. Hold on tight, winds here can reach 1,100 miles per hour. Such a gust of wind could carry you across the United States from one coast to another in just 2 hours. Hurry up and get on the scales, 144 pounds. It's a little more than you weigh on Earth. That's why you feel a little weaker, like after a good workout at the gym. Saturn's moon, Titan. You might want to stick around a bit longer because here you feel like a real weightlifter. You can lift 7 grown-ups in your arms, or a great white shark. Just be careful with those teeth. And your own weight here is about 17 pounds, like a domestic cat, maybe a fat tabby. Uranus is the coldest planet in our solar system. It's 10 times as cold there as in a freezer. The scales show 120 pounds. You could lift a truck wheel here. The last planet in our solar system, Neptune. It's 17 times as heavy as Earth and 4 times its size. And the strongest winds ever recorded blow here. The number on the scales is 150 pounds. Yep, you've gained a little weight. But the same would happen if you took a dumbbell in your hands on Earth. Now, how about moving to more unique space objects? For example, a neutron star. This is one of the heaviest and densest objects in the universe. A neutron star has the weight of the Sun, but it's so small that it would fit in Manhattan. But this space object has a solid surface, so you can land your spaceship here. The neutron star's weight and density makes gravity incredibly strong here. Your 135 pounds on Earth turn into 190 plus 11 zeros pounds here. You'd be flattened like a pancake on a neutron star. You wouldn't even be able to pick up a match here. A regular sewing needle would weigh 140,000 tons. That's like 2,000 Boeing 737s. Next in line is a black hole. Well, we don't even have a number to describe your weight here. Black holes are the densest and heaviest objects in the universe. They lie at the centers of galaxies and can weigh millions and billions of times more than the Sun. They're so heavy that they warp space-time. Once you're in a black hole's gravitational field, you can never get out of there. And the gravitational pull increases with every inch you get closer to the center of the black hole. If you were falling into a black hole and extended your arm forward, the force affecting your fingers would be much stronger than that pulling on your elbow, and your hand would stretch like spaghetti. Your weight is infinite here, and your strength is infinitely small. Don't even hope to lift a single atom or photon of light here. Yeah, that's enough. Let's go home.